Alright, so now let us see how to implement the breadth first search algorithm using queues. We have a graph here, and let's actually run this whole algorithm on it so that the concepts of which elements are being enqueued and dequeued from the queue are perfectly clear. So this box right here, with these steps 1, 2, and 3, this is what we do with every iteration of this algorithm. So I'm going to run this, and it will be clear to you now. We're going to start with the root node. Say here, for instance, I'm considering 1. So I'm going to start the BFS on 1. So as you can see, because I'm starting with 1 already is at the head of this queue, right? And this visited array, what is this visited array? It's a Boolean array where the values can be either 1 or 0. 1 indicates that the value or the vertex in the graph has been visited, and 0 would mean that it's not visited. So here, since we've already visited 1, you can see that the visited array of 1 is equal to 1. The rest all are zeros because we still haven't visited them. Alright, so the first step in the iteration of the algorithm is we dequeue. So I'm going to dequeue 1 from this, so my output would have 1. And then the next step is I push its children. So the children of 1, since it's a graph, the children would imply the adjacent vertices. And as you can see here, the adjacent vertices of 1 are 2 and 3. So I'm going to push 2 and 3 into the queue. And as you can see, the head would now point to 2. And then I update the visited array. When I say update the visited array, I want to update saying that, okay, I have visited 2 and 3 now. So since 2 and 3 are pushed into the queue, I'm like, hey, 2 has been visited, 3 has been visited. So 2 and 3 would become 1s. So that was one iteration. Now we move on. Next, we again dequeue from the queue. And as we know from the basics, the dequeue operation always happens at the head of the queue. So this time, we're going to dequeue 2. All right, and then we're going to push its children. So we can see that the adjacent vertices of 2 are 4, and yes, 5 is not an adjacent vertex because as you can see, the edge is pointing into 2 and not outwards. So we're going to push its child 4 into the queue. And we're going to update the visited array. So this 4 has been visited. So, I'm just keeping track that yes, I have visited the vertex number 4. All right, so that completes the second iteration. Now we move on again. We come back to the first step, dequeue. So we again dequeue from the head. Right? The head is now pointing to 3. So I dequeue 3. And I push the children of 3. Now I see that 3's adjacent vertices are 4 and nothing else, right? So I should be pushing 4. But 4 is already in the queue. That is exactly why we need this visited array. So before we push anything into the queue, we first check whether that vertex has been visited or not. So here in this case, we see that the child of 3 was 4, but this 4's value in the visited array is already 1. So we're not going to push that into the queue. That would just make it more redundant. Because it's possible that when you traverse the graph, we may come through that node again and again. That is why, that is the use of this visited array. So now we don't push anything into the queue and we don't update anything in the visited array. So that's done. Now we go to the next iteration. We dequeue again. So the head's pointing at 4. So we dequeue 4. And we see the children of 4 are 5. So we put 5 into the queue and we update the visited array as 1. Right? So now as you can see, the visited array, all of them have become 1s. So we have visited all the vertices. All right? And then we dequeue 5. So we have completed the breadth first search algorithm, and we have made sure that we visited all the vertices. And I hope you've understood how the values were enqueued and dequeued into this queue, and how this visited array kept changing with every iteration of the algorithm. Thank you.